Let me talk about the problem 5. The customer flow at a grocery store can be viewed as a Poisson random variable, which means P number of customer arrivals in time t equals to k. Is e to the power of lambda minus lambda t and multiplied by lambda t to the power of k divided by k factorial. And the problem says, suppose the probability that in 2 minutes at least one customer arrives equals to 0.3. And first, we will find lambda. We will transmit the probability in 2 minutes at least one customer arrives equals to one minus p at least one customer arrives in 2 minutes, which means it will equal to y minus 0 customer arrives in 2 minutes. And so it will be y minus e to the power of minus 2 lambda multiplied by 2 lambda to the power of 0 and divided by 0 factorial equals to 0.3. So we will have e to the power of minus 2 lambda multiplied by 2t to the power of 0 divided by 0 factorial equals to 0.7, and we will have lambda approximately equals to 0.178. The second problem is the probability 0 comes in 3 minutes, and we will just use the formulation. So it is e to the power of minus 3 lambda and 3 lambda to the power of 0 divided by 0 factorial, and it is just e to the power of minus 3 lambda. We will use the value of lambda we get from the previous, and we will have approximately 0.586. Yeah, it's just the value. And the third question is, at least 2 customers will arrive in 10 minutes. It is equal to the probability of y minus p 0 customer arrives in 10 minutes and minus 1 arrives in 10 minutes. So we will use the formula to get y minus e to the power of minus lambda 10 lambda and 10 lambda to the power of 0 and e to the power of minus 10 lambda, multiply 10 lambda to the power of 1 and divide by 1 factorial, and we will have y minus e to the power of minus 10 lambda is 1.78 and 1 at 1.78, so approximately be 0.531. And the last question is exactly one customer arrives in 1 minute. So just use the formula, which is e to the power of minus lambda and lambda to the power of 1 divided by 1 factorial, and it is lambda e minus lambda, and which is approximately be 0.149.